patches on the about it, and they are clay. When we apply the load, it gets the load. It does not return to its original brittleness. A material is said to be brittle when it. Hello friends, welcome to Civil Knowledge. Today I came with an important topic for every civil engineer, that is mechanical properties of solid. The most important properties of engineering materials are, the first most is elasticity. The property, let's see what exactly the elasticity is. The property by which a body returns its original position, returns its original shape after removal of external load, is called elasticity. A body which can regain its same position after removal of external load. For better understanding, let me show you a practical example. I have taken the rubber band. See the original shape of the rubber band. When we apply the external load, it gets stretched. When we remove it, it regains to its original position. So we can say that rubber band has elasticity. This material has elasticity. So that is known as elasticity. There are some examples: steel, copper, aluminium, stone, etc. may be considered to be perfectly elastic within certain limit. If it crosses the limit, it convert into plasticity. Now we talk about plasticity. Let's see what is plasticity. Plasticity is the property of a material by which a body does not returns its original shape after the removal of external load. Though we remove external load, the body or material, it does not regain its original position. For better understanding, let me show you a practical example. I have taken the clay. When we apply the load, it get compressed, and when we remove the external load, the body does not returns to its original position. So we can say that it is in plasticity. So though we remove the external load, it does not return to its original position or shape. So that's all about plasticity. Let's see what is ductility. Ductility is the physical property of a material that has ability to be stretched into wire without breaking. It is a material which can be stretched into wire without breaking is called ductility. For example, metals, gold, as we can say gold, when we heat the gold, we can give any design to it for making jewelry. It does not break, so we can say that gold has ductile nature. Silver, copper wares we have, this all are ductile nature. Though we stretch it drawn into wire without breaking, so it's called ductility. The next one is brittleness. A material is said to be brittle when it cannot be stretched into wire without breaking, and it takes place within a relative small deformation. So it is the material which cannot be stretched into wire without breaking. For example, cast iron, concrete we can say, and concrete cannot be stretched. it simply break. And some glass product, if you have glass, so it breaks instead of stretching. It won't stretch, it directly break. So we can say that glass is in brittle. It has brittle property. So that's all about brittle. And this one thing we came to know, that ductility and brittleness both are opposite, because ductility, material can be formed easily into wire without breaking. Here in brittleness, material cannot be formed into wire and it breaks. So we can say that both are opposite in nature. The next one is malleability. Malleability is the property by which a material can be uniformly extended in a direction without rupture, without any failure or break. It can be converted into thin sheet by hammering or rolling. As we can see in forging, when we heat the iron and we hammer it, it simply uniformly extend into the direction without rupture, or any failure or any break. That material is known as malleability. Any material on heating, on hammering, which is simply extended in a direction without rupture or any failure on a break, is simply known as malleability. For example, aluminum, gold, silver and copper. Aluminum can be uniformly extended in the direction without rupture. Yeah, this all metals are has the properties of malleabilities. Let's talk about toughness. Toughness is the ability of material to absorb energy and plastically deform without fracturing. What does it mean by plastically deform? Plastically deform means permanently deform. It absorbs energy and permanently deform without break, without any fracture, or fracture means breaking. Without any break, it can deform and it absorbs energy. That is known as toughness. Example, cast iron, concrete. Here concrete and cast iron absorbs energy and permanently deform without any crack or any fracture. It's known as toughness. Let's see what is hardness. Hardness is the ability of a material to resist indentation or surface abrasion. What is indentation? Indentation means any dent in the material. Hardness resists the dent, or surface abrasion means surface having scratches or roughness. So hardness resists the dents and any scratches on the material is known as hardness. For example, diamond has no scratches. Granite, concrete, quartz, ice, etc. are the examples of hardness. What is the main difference between toughness and hardness? Toughness absorbs energy, whereas hardness stop the dent, fight against dent, or stop have surface having scratch. So these are the most important properties of materials. So every civil engineer should know about it, and they are very necessary to know this property for designing any structure or building or anything. So this thing we should keep in our mind and we need to go ahead. Thank you for watching the video. Please subscribe our channel and like this video if you like, and comment us and share and press the bell icon for latest update. Thank you so much.